December 2005, a Soyuz from Baikonur successfully launches Giova-A. This satellite was essential to secure the frequencies allocated for the Galileo program. With Giova-A in orbit and the frequencies secured, Galileo could move forward. In 2008, Giova-B was also launched from Kazakhstan. It was the first satellite to carry the European-developed Maser atomic clock. This extremely stable atomic clock is now standard on all Galileo satellites. But 10 years ago, it was the most advanced clock ever flown for navigation purposes. The excellent test signals sent out by Giova-B were a prelude of what was yet to come. In 2011, the first complete Galileo satellites were launched. And by October 2012, ESA had 4 satellites in orbit. This is the minimum of satellites needed to determine a position, and ESA could start with the so-called in-orbit validation phase. On the 12th of March 2013, the historic first position fix using only Galileo satellites took place. The system was validated in orbit and worked well.
The quality of the signals from the Galileo constellation is very good. We have measured our signals with the signals coming from other systems like GPS or the Russian GLONASS and the Chinese Beidou. We know that at the moment our signals are among the best, so we're very proud of that.
In parallel with the construction of the space component, ESA was building a ground segment with 2 control centres to guide the satellites and disseminate the signal. One was built in Oberpfaffenhofen, Germany, and one in Fucino, Italy. At Europe's spaceport in Kourou, dedicated facilities are reserved for the deployment phase. During the last couple of years, ESA built and launched Galileo satellites in record time, using both Soyuz and Ariane 5 launchers. Now ESA is launching a third and final Ariane 5 with another 4 satellites.
With this we will have 26 satellites in orbit, 2 of which are in an elliptical orbit, which despite a slightly wrong orbit we can still use. One of the satellites is a reserve and another satellite is faulty and we cannot completely use it. So we will have more or less 24 satellites operational in orbit, and this is what the desired minimum is for full operations.
With the constellation up and running, the European Space Agency will further expand the ground segment in the years to come and launch more satellites, either as spares or as replacements for the older satellites. Starting in 2025, Europe will have a new and improved generation of Galileo satellites ready for orbit. Despite ESA going from a satellite navigation novice to expert in 15 years, the design and services of this second-generation system will be very much market-driven.
The market is, of course, a very important point for us because although in the beginning one could argue that this was very much a market which was pushed by technology and, if you want, by us, the market is now developing so fast and is going to be so enormous that we have an incredible responsibility. The market has expectations. They want us to come with new features. At the same time, they want to be capable to do the things they have done. They don't want unnecessarily to replace their equipment. So we need the legacy services to continue while we introduce new features.
A market that is booming. Industry, agriculture, rescue services, governments are all reliant on satellite navigation. And with the newest smartphones, which are Galileo ready, even the general public has this technology literally in the palm of its hand. With Galileo, Europe now has its own fully operational satellite navigation system, at a time where the importance of navigation services is only increasing.
Satellite navigation has become an integral part of our lives today. An area where satellite navigation plays a major role is air traffic control. For this safety-critical domain, the European Space Agency, ESA, the European Commission and Eurocontrol, the European Organization for the Safety of Air Navigation, developed EGNOS, which has been in use since 2011 and augments the existing GPS system. This increases the accuracy and the integrity of the position computed by the user. Nowadays, it has become an extremely reliable tool for pilots, helping them cope with whatever flying conditions they're faced with.
Now with the new EGNOS system, which is much more accurate than the normal GPS system, and we're able to get closer to the ground and be able to fly in weather that is with lower clouds or low visibility than we are used to.
Here in Denmark, bad weather or limited visibility is something that these air ambulances or rescue helicopters are confronted with all too often. Before EGNOS, up to 10% of the missions had to be cancelled due to poor weather conditions, a tragedy for patients whose safe and timely arrival at a hospital was often a matter of life or death. Now, with EGNOS, 3 geostationary satellites and a ground segment are working together to send an integrity signal to receivers in aircraft and helicopters. This increases the accuracy of the satellite navigation data to 1.5 meters, guaranteeing its quality and improving vertical positioning.
We need that accuracy because of the terrain. We're getting very close to the mountains, and that's why we need a very accurate satellite system, and also not only an accurate but also a reliable.
Today, the number of aircraft or helicopters using EGNOS is slowly rising. For instance, the Swiss Air Rescue Service, who fly over 11,000 missions a year, equipped their helicopters with the new technology, anticipating a nationwide adaptation of EGNOS. EGNOS is also relevant for civil aviation, as it can replace the traditional ground guidance systems needed for aircraft to land, providing a saving in the costs of local airport infrastructure. At Eurocontrol, experts are convinced EGNOS offers many benefits for aviation in Europe.
EGNOS can provide a more efficient service than we had in the past, including improving access to certain airports in adverse weather conditions. So better punctuality, fewer delays, less diversions to alternative airports.
More and more airports in Europe are now certified for landing approaches based on EGNOS. And what is happening in air traffic management will surely be extended in many other applications that need to rely on guaranteed satellite navigation signals. EGNOS will soon augment both GPS and Galileo navigation data. Relying on 2 constellations will further improve its performances and reliability.
Welcome back to Earth from space. The Vandenberg Air Force Base in California, where the Copernicus Sentinel-6 Michael Freilich satellite will soon launch from, is featured in this image captured by the Sentinel-2 mission. The area pictured here shows the Santa Barbara County in the southern region of the US state of California. Located around 200 kilometers northwest of Los Angeles, the county spans across 7,000 square kilometers and is bordered by the Pacific Ocean to the west and south. The county includes the coastal city of Santa Barbara, partially visible in the lower right of the image. Santa Barbara lies between the steeply rising Santa Ynez Mountains, visible in dark green directly above, and the Pacific Ocean. The mountains rise dramatically behind the city, with several peaks exceeding 1,200 meters. Other mountain ranges in the county include the San Rafael Mountains, visible directly above, and the Sierra Madre Mountains. Most of the mountainous area is within Los Padres National Forest, California's second largest national forest. The county's most populous city is Santa Maria, visible in the top left of the image, surrounded by a patchwork of agricultural plots. Like many other cities in California, Santa Maria experiences a Mediterranean climate. Below Santa Maria lies the Vandenberg Air Force Base, visible along the coast. It is here where the Copernicus Sentinel-6 Michael Freilich satellite will launch from. A joint European-US satellite built to monitor sea levels, the satellite will lift atop a SpaceX Falcon 9 rocket on Saturday, 21st of November. The satellite was named after Michael Freilich, the former NASA director who advocated for advancing satellite measurements, and will extend a nearly 30-year continuous dataset on sea level. It will be the first ESA-developed satellite to be given a ride into space on the SpaceX Falcon 9 rocket. Famously, Falcon 9 is partially reusable, unlike most rockets. Once in orbit above Earth, the Sentinel-6 Michael Freilich satellite will collect sea level measurements for 95% of Earth's ice-free oceans. The data will be essential for climate science, policy making, and protecting those in low-lying regions.
Copernicus Sentinel-6 Michael Freilich. Rising sea levels are one of the most threatening consequences of climate change. Since we've been burning coal, oil and gas to fuel power plants, transport and modern life, an increasing amount of greenhouse gases has been added to the atmosphere. This has caused heat to be trapped on our planet, and every year our world is getting hotter and hotter. This extra heat is causing glaciers and polar ice caps to melt and the ocean waters to warm up. As land ice melts, it flows into the oceans, making sea levels rise. And as the oceans warm, the seawater expands, also making sea levels rise. For the past 3 decades, scientists have seen an average rise of 3 millimeters every year. This is faster than coral reefs grow. By the end of the century, the sea level is expected to have risen by 1 meter compared to what it is today. This is a serious threat for the many millions of people that live in coastal regions around the world. For example, New York and Shanghai will be at risk, and low-lying countries like the Netherlands will have to spend a lot on sea defense systems. Countries like Bangladesh will face serious problems. This scenario might seem distant, but worryingly, it's very likely to happen within the lifetime of all the children who are born today. That's why governments worldwide have started preparing for the rising water. To take the right action, they first need long-term, reliable data about how fast and by how much seas are rising. Earth observation satellites have provided these figures for decades. The gold standard of sea level data has come from the Topex, Poseidon and Jason satellites since 1992. They have been key cooperation projects between Europe and the United States. Now, the European Commission, together with ESA, EUMETSAT, NASA, NOAA and CNES, are launching a new satellite mission as part of the Copernicus program. Sentinel-6 will not only carry on measuring the sea level, but also do it with greater precision than earlier satellites. But is it feasible to measure sea level change from a satellite in orbit high above our heads? Yes, it is. Sentinel-6's main instrument is a radar altimeter. It sends radio waves down to the surface and receives their echo. The shorter this takes, the higher the sea surface. To make the mission even more accurate, the radar is supported by various other instruments that determine the satellite's precise position above Earth. Still, how can a satellite distinguish a few millimeters of sea level rise from the effects of waves and the wind, from currents and tides? In fact, it can't, but scientists can. The satellite overflies the same spot thousands of times, and all the data are averaged to work out exactly how and where seas are rising. What scientists finally obtain is the net increase in ocean level for the world's oceans, as well as inland lakes. These data will be precise down to a millimeter and will continue the record of sea level rise for at least another decade. With these predictions and calculations, public authorities will know where to fortify dikes, harbour buildings and quays, how to approach coastal defence and how to relocate settlements along the coast. The data will be used for policy to tackle climate change. Data will also enhance weather forecasting at sea, as well as help forecast cyclones, droughts and heat waves. These data are important for the whole world. The Copernicus Sentinel-6 mission is a collaborative project between the European Space Agency ESA, the European Commission, EUMETSAT, NASA and NOAA, caring for the future of our planet by charting the sea level.
The Pacific Ocean next to Vandenberg Air Force Base, the launch site for an important ocean mission. Here, over the past few weeks, preparations have been made for the launch of Sentinel-6 on a SpaceX Falcon 9 rocket. Because of the COVID-19 pandemic, many of the team are working remotely in Europe, with only a few engineers able to make the final checks on the satellite.
Well, for all of us, the launch campaign is the culmination of many years of work, and to actually see the satellite in its usually most beautiful state, when you've got all the covers off, you've got all the final blankets on, for all of us, it's a wonderful moment, it's emotional, and to see it as you see it here, nicely on the adapter for the launcher, we are really proud and looking forward to the launch.
Equipped with a radar altimeter, Sentinel-6 will make the most accurate measurements yet of sea level. A joint project between Europe and the United States, Sentinel-6 will continue the legacy of almost 30 years of radar altimetry missions, starting with Topex Poseidon in 1992, and continuing through Jason 1, 2 and 3. Providing an accurate record of sea surface measurements and proving that mean global sea levels are rising.
We want to continue that record for another 5 years and demonstrate and quantify the sea level rise we have been observing since the 90s, in average about 3.2 millimeters per year, even though the scientists tell us in the last year this has been accelerating, in particular due to the acceleration in melting of ice. So over the last years, it's above 4 millimeters every year we record in the sea level.
Sentinel-6 will map up to 95% of the world's oceans every 10 days. Taking continuous measurements of sea surface and wave height, as well as wind speed, the satellite will also provide vital safety information for shipping through marine and meteorological forecasts. It will operate alongside other Sentinel satellites as part of the European Copernicus Earth Observation Programme.
For me, to be part of Earth observation is special because you really do feel you're doing something that can help the future of mankind.
These are the last views of Sentinel-6 before it's covered by the fairing for launch. If all goes to plan, the satellite will soon be in orbit, providing vital data to help us better understand our changing world.